Hey there, Seahawks. It's Miss Adams, and in this video, we're going to learn about a binomial random variable. All right, a binomial random variable is used in a probability experiment that, one, is repeated for a fixed number of trials, where each trial is independent of the other trials. Two, there are only two possible outcomes of interest for each trial, a success and a failure. The probability of success is the same for each trial, and the random variable x counts the number of successful trials. So there's a fixed number of trials, there's only two outcomes, success and failure, the probability stays the same, and we know how many successes, like x will be the number of successes. All right, binomial calculations in the calculator. So there's a binomial PDF function in your calculator. I like to think of the PDF as precise, which is the exact number of successes, like probability of getting exactly 5 successes. CDF is cumulative density function, so find the cumulative probability for that value and all the values below it. So it's like a less than or equal to that value. To get to this, you go to the distributions menu, so it's second bars, and that'll pop up the distribution menu, and then you scroll until you find option A and B on most calculators. It's binomial PDF and binomial CDF. Open binomial PDF or CDF, depending on the problem that you're asked, and then it'll pop up a screen, and you just fill in the information. So in the trials, you'll put the number of trials. P will be the probability of success. X will be the number of successes that you're going until. And then hit enter twice, and you will get your answer. All right, number 1, a card is selected from a standard deck of cards and then replaced. This experiment is repeated a total of 4 times. Find the probability of selecting exactly 3 diamonds. All right, so N is 5. P is 0.25. And Q, which is 1 minus P, is 0.75, and X is 3. All right, so a card is pulled, and then it's repeated 4 times. That's where I got the 5 for N. Probability of success is 25%, because 25% of the cards are diamonds. Probability of failure is 75%. So I want to find the probability of exactly 3. So probability X equals 3 would be 5 choose 3 times the probability of success to the 3rd power times the probability of failure to the 5 n minus x power, 5 minus 3. Okay, or if you don't want to use the combinations and remember that formula, this is exactly 3 times, so it's precise. So you do a binomial PDF, so second bars, distributions, find binomial PDF. Trials would be 5. Probability, P, would be 0.25. X would be 3. And you get 0.0879. Austin makes 80% of the free throws he attempts. He is going to shoot 5 free throws. Assume that the results of free throws are independent from each other. Let X represent the number of free throws he makes. Find the probability that Austin makes at least 3 of the 5 free throws. All right, so I have 5 attempts. The probability of success is 0.8. N is 5. X is going to be 3, at least 3 means 3 or more. All right, so I want 3 or more. When I do a binomial CDF, it does that value or less, so less than or equal to that value. So if I want the probability of X is greater than or equal to 3, I'm going to have to do 1 minus the probability X is less than or equal to 2. All right, so if I want 3 or more, I'm going to have to get rid of the 2 or less. All right, so I'm going to do 1 minus a binomial CDF, where N is 5, P is 0.8, and X is 2. I get 1 minus 0.05792, which works out to be 0.94208. So there's a 94.2% probability that Austin makes at least 3 of the 5 free throws. Okay, well, he's an 80% free throw shooter, so that's pretty likely. All right, a binomial distribution. X is the number of heads from flipping 5 coins. All right, so if I wanted to do this more of the long way, I have to figure out how many possible outcomes I could make with 5 coins. Well, I have 2 outcomes when I flip a coin, heads or tails. So it's a success or a failure. So it is binomial. Each time I flip it, they're independent. They said 5 times. I have a fixed number of trials. So heads or tails, 5 times. So 2 times 2 times 2 times 2 times 2 is 32. So there's 32 possible outcomes. The probability that I get 0 heads when I flip it 5 times would be 5 choose 0 out of 32. Well, 5 choose 0 happens 1 out of 32 times. Okay, or you could even make like a tree diagram, heads, tails, 5 times, but that would be a lot. Because in the end, there'd be 32 little branches. If you don't want to use the combinations, it'd be binomial PDF. N is 5, P is 0.5, X is 0. And that comes out to 0.03125. All right. Probability X equals 1. 5 choose 1 out of 32. 5 choose 1 is 5 out of 32. Works out to be 0.15625. Okay, or you could have done a binomial PDF where N is 5, P is 0.5, and X is 1. So you can do a binomial PDF for all of these. And you can kind of see it starts to increase and then it starts to go down. So it kind of gives you more of a normal distribution look. All right, so I want to show you how you could do this in your calculator. So I have this distribution. So I'm going to go to Stat, Edit, and I'm going to clear my list. And I'm going to put in list 1, 0, 1, 2, 3, 4, 5. Those are the amount of heads I could get when flipping 5 coins. I could get 0 heads, I could get 1 head, I could get 2 heads, I could get 3 heads, 4 heads, or 5 heads. Okay, now I want to find the probability of that happening, which I know it's a binomial distribution. So I'm going to go up to the top, highlight list 2, and hit enter. And down where it says list 2, you'll see that flashing black box. Now I want it to follow a rule. I always want it to do a binomial PDF. So I'm going to go to second bars. I'm going to go to binomial PDF. Hit enter. My trials was always 5. My probability of success was always 0.5 because there's a 50-50 chance that you get heads or tails if it's a fair coin. And X, the X value that I'm going to use is the X value that corresponds to the number in list 1. So I'm going to hit second 1 to put list 1 there. And then I'm going to hit paste. Okay, so that's going to go, that rule is going to get put into list 2. And when I hit enter, it's going to calculate all of those probabilities for me. And you can see that they match here. All right, go Seahawks.